Hello, this is the second of two videos on exponential models, as shown here in the syllabus. An exponential model has the variable in the power. If the exponential function is increasing, it can represent growth. If the exponential function is decreasing, it can represent decay or loss. The general form of an exponential model is f of x is equal to k times a to the power of rx plus c, where k, a, r and c are constants. The y-intercept is the point 0, k plus c, and the equation of the horizontal asymptote is y equals c. Remember that the constant a is called the base. The initial value is the value of the function when x is equal to 0. It corresponds to the y-intercept of the graph. So the initial value is equal to k plus c. Note that x usually represents time. In part A of this question, we're asked to sketch a graph to model how much Bailey has in the bank after x years. We need to identify a suitable model. The present value is $2,000, the interest rate is 4.5%, and the interest is compounded monthly. You should be familiar with the compound interest formula, which is given on page 3 of your formula booklet. Substituting the given values into the formula and replacing n with x, the time in years. It's advisable to simplify the formula, as shown. To draw the graph on the calculator, from the main menu, select Graph, type the equation into y1, so that's 2,000, bracket 1.00375, close bracket, raised to the power of 12, and then press the X variable button for X. Press Execute to enter the equation. At this stage, we can press Shift F3 View Window to set up an appropriate window. For the X values, I'm going to set -3 for X min, 20 for X max, with a scale of 4. For the Y values, I'm going to set 0 for Y min, 5,000 for Y max, with a scale of 1,000. Press Exit, then F6 to draw the graph of the function. Make a neat sketch. Show scales on the axes. Label the axes and identify the y-intercept. In part B, we're asked to calculate how much money Bailey has in the bank after 4 years. Using the calculator, this is a y calculation. Press F5, G-solve, F6 to get to the second page of tabs, and F1 for a y calculation. Enter the value of x, which is 4 for 4 years, and press Execute. Write down the value of y, which represents FV, the future value. So after 4 years, there will be $2,393.63, correct to 2 decimal places. In part C, we're asked to calculate how long it will take for Bailey's money to double in value. Starting by finding that future value, double 2,000 is 4,000. Then writing an equation replacing the future value FV with 4,000. On the calculator, this is an X calculation. Pressing F5, G-solve, F6 to get to the second page of tabs, and F2 for an X calculation. Enter the Y value, 4,000, and press Execute. Write down the value of X. So it will take 15.4 years for Bailey's money to double in value, correct to 3 significant figures. In part A of this question, we're asked to find the original affected area, which is the initial observation when the number of weeks n is equal to 0. Replacing n with 0 and simplifying gives A is equal to 1,000. We could have also used the formula K plus C, since K is equal to 1,000 and C is equal to 0. Alternatively, we can use the calculator. From the main menu, select Graph and type the function into Y1. So that's 1,000 multiplied by 1.15 raised to the power of x, pressing the x variable button. Press Execute to enter the function, and then press Shift F3, that's View Window, to set up a suitable window. For x, I'm going to set -5 for x min, 20 for x max, and 2 for the scale. And for y, I'm going to set 0 for y min, 10,000 for y max, and a scale of 1,000. Press Exit, then F6 to draw the graph of the function. To find the y-intercept, press F5, G-solve, followed by F4, y-intercept, given the same value as before. So the original affected area is 1,000 hectares. In part B, to find the area affected after 10 weeks, we can either substitute that value, 10, into the function and simplify the result as shown, or alternatively, we can use the calculator. This is a Y calculation. Press in F5, G-solve, F6 to get to the second page of tabs, and F1 for a Y calculation. Enter in the value of x, 10, and pressing Execute, given the same value as before. So an area of 4,050 hectares is affected after 10 weeks. In part C, we're asked to sketch the graph of the function. So we should make a neat sketch showing values on each axis, labeling each axis, and identifying the y-intercept. In part D, we're asked to find how long it would take for the affected area to reach 8,000 hectares. If we first state an equation replacing A with 8,000, and then use the calculator. This is an X calculation, so press F5, G-solve, F6 to get to the second page of tabs, and then F2 for an X calculation. Entering the Y value, 8,000, and pressing Execute. Writing down the value of X, which represents n. So it will take 14.9 weeks for the affected area to reach 8,000 hectares, correct to 3 significant figures.